So we'll go through these one by one. Correlation coefficient we have seen last time. We'll do a linear regression analysis today. All of you type LRA in the chat box for linear regression analysis. Come on, let's have an awesome session today. And correlation, we said it's a scatter plot. It's a relationship between two variables. And regression is actually trying to predict the relationship with an equation. Predict the relationship with an equation. So correlation is a quick recap of last time. Correlation measures the relationship between two numeric variables, whereas regression measures how these two numeric variables affect each other. How strongly they affect each other. How does the factor affect each other? If this is clear, type SC, super clear in the chat box. If it is clear, type super clear in the chat box. So we said that correlation, regression are statistical concepts. Okay. These are the tools to calculate the input, as input is related to the output. Temperature versus time. If you keep the gas on or the heater on with respect to the temperature, with respect to the time, the liquid temperature insides keep increasing. So there is a relationship between time and the temperature when the heater is on. The concept of correlation and regression was already introduced in the earlier chapter. So we will go into the depth of regression, linear regression in this chapter. Okay. Last time we saw something called the correlation coefficient. It is a number which describes the strength of relationship. So a quiz question that I asked is, what is that number? So the correlation coefficient number varies between what and what? Please type in the chat box. Those people who attended my last session will be able to answer this question. -1 to +1 is the right answer. So the numbers range from -1 to +1. And now I'm going to introduce something called a COD. All of you type COD in the chat box. Coefficient of determination. Coefficient of determination. Coefficient of determination is square of correlation coefficient. If you square correlation coefficient, it is called coefficient of determination. So if you square +1, what is the number you will get? +1 squared is how much? Come on, quickly put in the chat box. Square of 1. What is the square of -1? Again, it is 1. So coefficient of determination varies between 0 to 1. Okay? Which is called R square. It is called R square. Coefficient of determination is also called R square. R square is a number, a measure, which establishes the degree of relationship. All of you type DOR in the chat box, degree of relationship. Just to tell you a simple example of R square is 50, only 50% can be explained by an equation. The remaining thing is unexplained. If R square is 90, 90% can be explained in this equation. So the equation is much more predictable. Okay? All right. Now let's get into what is a regression analysis. So once you know the data has a linear correlation, once you have the correlation, which is a strong correlation, which is a linear correlation, we can conduct further analysis through regression. Okay. So today what we are going to do is, we are going to quickly establish a relationship between two variables, find out the correlation coefficient, find out the correlation of determination, find out the equation, predict from the equation what can be possible values. Are you ready? Type ready in the chat box. So as I said, coefficient of determination is nothing but square of correlation coefficient. If correlation coefficient is 0.86, R squared is 0.7. Just an example. Okay. So as you said that R squared will be 0 to 1, it determines strength of the relationship. In our example, R square is 0.74, which means that approximately 74% of the variation in temperature is related to change in time. Remaining 26% is unexplainable. Okay, if this is clear on a scale of 1 to 10, please give me a 9 or 10. Can I open an Excel sheet and practically take you through the steps of how to do the regression analysis in Excel? Okay, all of you, how many of you are excited by this? Type X in the chat box if you are excited. Once you type X, I will open Excel. Okay, good. All right. Now I'm going to open a new blank file. Okay, and I'm going to share that blank file with you. If you can see the blank file, type yes in the chat box or B in the chat box if it is a blank Excel file. Good. Okay, thank you very much. So don't forget to join the upcoming session where I'll be talking about how to get the certification. Okay, now let's assume that there is a vessel, okay, where there is a heater, vessel with a heater. There is a liquid inside and we are going to heat the liquid. I'm going to switch on the heater and observe the time and the temperature. I'm going to see whether I have 4 vessels like that, okay, 4 liquids like that. So I'm going to, temperature A is of vessel A. Can you all see my data? I've just copied the data here. And if you can see the data, type yes in the chat box if you've seen the data. Temperature A, temperature B, temperature C, and temperature. Awesome. Thank you very much. Okay, so these are the numbers, temperature data that I had copied. Okay, if you want, you can take this, but I'll share this Excel sheet also with you, not to worry. Okay, okay. Now, the first step, we are going to calculate 3 things. First, we are going to calculate the strength of the relationship between time versus temperature. All of you type time versus temperature in the chat box. We're going to see time versus temperature. And I'm going to take time versus temperature of 2 different vessels. Let me de-highlight this. Okay, last time we have seen this example, so I'm going to de-highlight this. Okay, and I'm going to de-highlight this. I'm going to take only 2, the temperature A and temperature C with respect to time. So the first thing is, let's take, first of all, time and temperature A, we will establish, we'll see whether there is a relationship or not. So the first step I do is, I'll go to insert, I'll do a scatter plot by taking time A and time B and do insert a scatter plot between these 2. Okay. So if you feel this, simple, type simple in the chat box if you felt that the scatter plot was simple. All of you type simple in the chat box. Very good. Now the question to you is, please, question to you is, I want active participation. Is it positively correlated, negatively correlated, or not correlated? Tell me, what is it? How is it correlated? It is positively correlated. Very good, very good. Because as the time increases, the temperature also increases. But can we say the strength of this relationship? The strength of the relationship is by correlation coefficient. Can we tell any number between -1 to +1? How strongly it is? If it is totally, completely correlated, then it is +1. But is it 1 or lesser than 1? How much it is? Everybody says it is +1. Somebody says 0.9. Balaji says it is 0.75. Balaji Gururajan. Balaji Gururajan seems to be an experienced person. I still remember your earlier comment. Okay. All right. So let me exactly calculate and tell you how much is. So what function did we use last time? Anybody remember the function that we used last time? Quickly put it in the chat box. Come on. I'm not telling you immediately because I want somebody to recall and participate and tell you. Yes. Correct. Congratulations. It is corral. Okay. So the correlation coefficient is equal to CO RREL correlation of the time comma, the temperature A, and what's the number that we are getting? If you see the number, everyone type the number that you see. This is correlation coefficient, 0.98. Okay, so coefficient of determination, how much is it? This is called R square, right? Which is equal to this into this R square. This is coefficient of determination. All right. Now we are going to do, we have done scatter plot. We have seen the relationship. Now we have calculated the strength of the relationship, and strength of the relationship is pretty good. It's almost equal to 1. It's 0.98. But what is the equation and how can we predict it? Okay. So what I'm going to do here is, I'm going to go to data analysis. I'm going to do a regression. Okay. All of you type data analysis regression. Okay. Data analysis regression. Okay. Data. I'll share this in the screenshots in the Excel. Okay. So please write down data analysis regression. Fantastic. Good. So now I'm going to this regression. I'm clicking OK. Now input. So input value, input Y range means which is the cause, which is the effect. I have time and temperature, which is the cause and which is the effect. Time is the cause, very good. Temperature is the effect, because we have put the heaters on with respect to temperature, time, it is temperature is the effect. So effect is the output. All of you put effect is equal to output. Okay. And output is equal to Y. Y is the output, X is the input. So in the Y, what I'm deleting this, and in the Y, I'll put the output, which is temperature A. Okay. And in the X, which is the input range, I'll put the time. Now I've clicked on labels here because on the top line, the row number 1, I put the labels. So I'm telling Excel that I have a label on the top, which is time and temperature, because I've chosen including the label. I put that into a new ply. Okay. And we will line fit the plots. Okay. So far, if it is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super clear on this. Yes, I will share this lecture for sure. Please stay till the end. Okay. So far, if you're finding it interesting, useful, fantastic, awesome, put it in the chat box so that I can draw inspiration from you and go ahead with the session today. Superb. Okay. Thank you very much. Yes, we can get the recording of this. Don't worry. Just focus on the session. Please focus on the session. If you like this, you will also get international certification. So please join in the upcoming webinar so that I'll tell you how to get international certification. So I put the Y range, I put the X range, I click OK, and I see something like this. Let me click on this. And in the format, let me make it bigger so that all of you can see it. So I got a plot. Okay. So in this plot, the orange one is the predicted temperature, and the blue one is the actual temperature. Okay. If this is clear, all of you type super clear in the chat box. The orange one is the predicted temperature, and the blue one is the actual value that is seen. Okay. If you see from sheet 1, 30, 35, all this is actual values, and this is predicted values. Okay, I'll come here. We've already seen something here, which is the correlation coefficient and coefficient of what did we write here? Determination, right? COD, which is R square. Okay. So R square. The same value, whatever we got there, we have got here. I will highlight this for you. And I'll tell you 0.98, 0.96 is what we had also seen from 0.98, 0.96. The same value, 0.9626 here. Okay. Coefficient determination. So all the other things, we will explain it later. But what I want to tell you is there is a plot. And now we want an equation for this plot. Okay. Why do you want the equation? Because we want to predict. That is what is called as the linear equation. Okay. So what I'm going to do here is I'm going to click on this chart. Okay. Then on the top, I get chart design. I will get only if I click on this chart. Okay. So I'll have to click on the chart. Then I get this chart design and add a chart element. And there is a trend line here. Okay. I will go to trend line here and more trend line options. And predicted temperature is what I wanted to add a trend line to predicted temperature. If I see OK, I'll get a trend line on the predicted temperature, but I'm going to say display equation on the chart here. And once I display equation on the chart, I get this equation here. How many of you can see this equation type ICS? I can see in the chat box. See, I'm teaching you the Excel route because there are statistical software which will give you instantly, but Excel is widely used to software, and I hope you are finding it useful, interesting, valuable, fantastic, awesome. Okay. Now, if I want to predict, so y is equal to 3.349x plus 27.561. This is the equation. In this equation, some people said y is equal to mx plus c, where c is a constant. So the constant is 27.561. That's a constant. And the slope, which is m, okay, I'll put it as small m, is 3.3497. And input x can be 1, can be 2, can be 3, can be 4, can be 5, etc. We have up to 12 here. So the equation prediction is y is equal to mx plus c, which is equal to m into x, m into x plus the constant, which is c. Just 1 second, I'm sorry. I'll delete it again. I'll do it again. I put 2 pluses here, is equal to m into x plus c. Okay, 30.9. If you can see 30.91, you can say yes in the chat box if you can see that. Okay, this is the prediction. But what is the actual? The actual we have seen in sheet 1 is actually 30. These are the actuals. These are the actuals. If it is clear, type SC, super clear in the chat box. This is the prediction based on the equation. This is actual. So difference is called residuals. The difference is called residuals. All of you type residual in the chat box. The difference is called residuals. So residuals is equal to this minus this, which is 0.971. The same thing we can do for all the others, okay? And you can see the residuals here. Okay. Now, the difference is called as residuals. So why are we talking about residuals? Because the more is a residual, that means the more is a deviation from here. So the residual should be smaller. That's what we want. We can also predict something like that. Let me tell you how you can predict, okay? Suppose I want, let's say, I want to predict what should be my input temperature. So that, what should be the time for my temperature to be, let's say, 40? And what should be the time for my temperature to be 50? If it is clear, type super clear in the chat box. I want to predict what should be my time, how much time it will take for it to reach the temperature of 40, how much time it will take for the, so we can use goal seek here. All of you type goal seek, and in the goal seek, you set this to 40 by changing cells here. Okay, so I'm not put the formula here. So let us put along with the formula. So here, tools goal seek, set this to 40 by changing cells here. So how much is the time taken? In how much time will you reach the temperature of 40? Please put it in the chat box. how much time it will take to reach the temperature of 40. And similarly, let us do, so it will take 3.7 minutes, okay? And similarly, let's do to reach 15 minutes, how much time it will take. So 2 is goal seek. So set the cells to 50 by changing the cells here and type OK. So how much time will it take for you to reach temperature of 50? So it will take about 7 minutes. All right. So coming back here, let us quickly recap what all that we have learned. So far, if you're finding it useful, interesting, fantastic, awesome, just put it in the chat box and we'll do a quick recap of what you've learned. So we have taken this temperature, we have seen this table, and we have gone to, okay, let me pause the chat for some time because we have limited time. Let me quickly share with you. If you liked this, I sincerely, strongly recommend that you join the upcoming webinar for my certification session. Okay. So you've got this. I put the screenshots here. I'll share this presentation towards the end of the session. Okay. So creating a regression worksheet is in the following steps. So we copy the data into the table. We have done that. We have selected data analysis tab. This is a quick recap of whatever I've demonstrated. Okay, then I chose the regression. From regression, I chose the input range, the output range. I've selected labels and line fits and to the new ply. Okay, so this is what I've done. Okay, now the third step I've done is we have seen what is the correlation coefficient, coefficient of determination, all that we have seen from this. We have also calculated by other formula also, Corel formula also. Okay, so these are the two values that is of interest to us. Other things we'll discuss deeper later. Okay. Now, so you will find multiple R and R squared in Excel. Okay. Now we generated the Twitter line plot. Okay. And we have determined the correlation coefficient, all that. And R square, we saw it was 0.96. And what it means that is 96% is explained by this equation. Okay. It is related to time and it is explained by this equation. Okay, so now we went to the add chart element. I have shown you, I've demonstrated this to you also. And then on the Excel graphs, we selected the design and select add chart element. We went to more trend line options and we selected the predicted temperature A. And then finally, what we found was we found an equation here. Display the equation in the chart and we got an equation. What is the equation? We got equation 3.3497x plus 27.561. We've already seen that. Okay, this is what we have got. So if you recall, the R square was 0.96, which means that our linear equation is going to be very good at determining the approximate temperature in our process as a relationship to the time. So we have also demonstrated at 5 minutes. We have seen that actually at 5 minutes, it's 44.30. Okay, so we put it in this equation. And at 25 minutes, you can put it in the equation. You can see that as 111.30. And we can also check this model, okay, with other temperature B, temperature C, and temperature C, okay. And you will get an equation like this. Where there is no correlation, the residuals will be much higher because there is no correlation. And if you see that the actual values are very away from the predicted values, so there is no correlation. So this equation, which is y is equal to this particular equation for temperature C, which is not correlated much, is not valid. Okay, you cannot do it from this. Okay, if you see the actual temperature was 75, but then the equation predicts 40, which means that the equation is not reliable. So first we need to see the R square value, that is how strong. I mean, correlation coefficient is the strength of the relationship, and R square is how much percentage can be explained by this factor, which is the time. Okay, this we have seen here. Okay, so I'm not going to read through all this. I have explained to you all this. Okay, and we have also predicted for 40 and 50 also. I have shown you that 3.71 when to reach the temperature of 40, you need 3.71 minutes. To reach the temperature of 50, you need 6.69 minutes. That also I demonstrated through Excel. Okay, so you can read this as theoretical, okay, as notes. Now I'm going to have some questions. Okay, are you ready for Q&A? Let me quickly ask you this question. All of you type ready in the chat box. I'll ask you the question. And there's one question which I not covered here is a p-value, because if the null hypothesis for this regression equation is, okay, there's no regression, and the alternate hypothesis is it is regression. So if p-value is low, the null must go, okay? And if p-value is high, the null is high. So if p-value is low, that means there is regression. Okay, we'll see that later, but I'll ask a question. What is the primary purpose of regression analysis? To find the correlation between two variables, to predict the value of the dependent variable based on one or more independent variables, to compare the averages between the groups, and to test the significance of population means. Yeah, let me know your thoughts in the chat box. What's the right answer? So the correct answer is to predict the value of the independent. I've also given the explanation here. Okay. So congratulations for those people who have typed B. So the second question. This is the second question. There are totally 5 questions. There are 4 more questions. Okay. There are 3 more questions after this. The regression model, the residual, is defined as the predicted value of an independent variable. Residual. Okay, I explained to you what is residual. Difference between observed and predicted values, slope of the regression line. Let's see in the chat box. What's your answer? B. Fantastic. So that's right answer. Thank you very much. Let me pause the chat box. The correct answer is B. The difference between the observed and predicted values, residual, is an error term, right? The actual error. Fantastic. So another 2 more questions. Which of these values, following values of R square, indicates the best model of fit? R square is 0.1, R square is 0.5, R square is 0.85, R square is minus 0.75. Which square indicates the best fit? All right. Okay. And R square is between 0 to 1 only. It cannot be negative also, right? Okay, fine. That's the right answer. Thank you very much. It's interesting. Okay, so the question is, what does multi-collinearity in regression model imply? Multi-collinearity. Okay, dependent variable is highly correlated with itself. Independent variables are highly correlated with each other. The residuals are normally distributed. The sample size is too small. Okay, now I have not covered this in this session, but still, okay. But still people are answering well, okay. Independent variables are highly correlated because I've seen only one variable, temperature versus time versus temperature, I've said. Okay, temperature must be influenced by other factors also, maybe ambient moisture levels and stuff like that. Okay, there can be other factors. So if those 2 factors are correlating with each other, it is called multi-collinearity. Okay. Independent variables are highly correlated to each other. Multi-collinearity refers to a situation in regression where 2 or more independent variables are highly correlated, leading to unreliable coefficient estimates and difficulty in interpreting the model. Okay. You cannot interpret with this. Okay, last question is, what is the role of p-value in regression analysis? Okay. It shows the size of the data set. It indicates whether the model overfits. It tests the null hypothesis that regression coefficient is 0. And it measures the R square of the model. So let's see. Okay, null hypothesis that regression, there is no regression. Null hypothesis, there is no regression. Okay. And alternatives, there is regression. In regression value, p-value helps in determining the statistical significance of the predictor. If p-value is low, it suggests that the variable significantly contributes to the predicting outcome, which means there is a linear regression. All right. So we come to the end of the chapter. If you found today's session interesting, useful, fantastic, valuable, Put in the chat box, give me some inspirations.